Let's consider this case. A block of mass 0.5 kg hanging from a vertical spring executes simple harmonic motion of amplitude 0.1 and time period 0.314 seconds. Find the maximum force exerted by the spring on the block. Let's see the solution of this case. Now this is a case of vertical SHM, in which the equilibrium position is not the natural length, it is the position where the net force is equal to 0, and that happens when a force of kx0 is balanced by mg. So let's call this to be the natural length in this particular case, and this to be the mean position in this particular case, where the distance between the mean position and natural length is actually equal to x0. So the extension in the spring would be equal to spring would simply be equal to x0. And if we see over here, there is a downward force of mg which is equal to 0.5 into g, or 5 newtons, that is balanced by a force of k into x0. So if this particular state is mean position, so Fnet has to be equal to 0, or kx0 has to be equal to mg, or 5 newtons. So from there we come to know that kx0 is actually equal to 5 newtons. Now it is given that the particle has an amplitude of the particle is given to you as 0.1 meter. So spring can further be extended through an amplitude, and over here you will get a force of k times x0 plus a, which is the maximum spring force. The maximum spring force would be simply equal to k times x0 plus a, where k, this can be broken down into kx0 plus ka, where kx0 is equal to 5 newtons and k is something which we do not know up till now, and a is given to you as 0.1. If the value of k is known to us, everything can be solved up in this case. For the value of k, we have been given that the time period is equal to 0.314 seconds, which can be written as 2 pi under root of m by k. So solving this thing, 3.14 divided by 10 is equal to 2 into pi into under root of m can be written as 0.5 divided by k. Solving this particular part, we will get to know that k comes out to be equal to 200 newtons per meter. If k comes out to be 200 newtons per meter, the force in this scenario comes out to be equal to k times x0 plus k times a, which is the maximum spring force, which comes out to be 5 plus 200 into 0.1, or 5 plus 20, that is equal to 25 newtons. So the maximum spring force in this case comes out to be 25 newtons, which would be the answer to this